So a lot of Chapter 4 is going to deal with trig functions, so sine, cosine, tangent, and then secant, cosecant, and cotangent. The one thing, whenever we get into the majority of the trig functions, we'll talk more about how you name things and stuff like this. A lot of what we'll do today is going to be a lot of review. There's going to be some new, but for the most part, it's a lot of stuff that you've seen in geometry, but now it's just the more technical side of it. There's a lot of definitions. There's a lot of kind of easy little tricks and stuff like that as far as how we start to deal with certain things and kind of just the overall main aspects of trig. So with 4-1 and angles and radian measurement. Okay, so for the most part, whenever you were in geometry, you only dealt really with angle measurement. You didn't really see probably anything at all of radian measurement. Okay, even though you know what certain things are, okay, namely pi. Okay, it's just the two different ways of writing a measure of a trig function is either with its angle or in degrees or radians. Okay, whenever you had like a scientific calculator, okay, and you can even do this with a graphing calculator, but whenever you had a scientific calculator, probably whenever you were starting out in like junior high or whatever, and you had like a DRG button at the top, and it probably had like a little arrow, and you could hit that button and it would say, probably at the top it would say like DEG, okay, or if you ever noticed that, it said like DEG. If you hit it again, then it maybe said, it probably said rad, okay, which stands for radian, and then it probably had another one where it said grad on there, which is gradient measurement. That is one that we won't use. Okay, we're going to stick with degree measurement and radian measurement. All radian measurement really means is that we're going to write it in terms of pi. Okay, degree is degree. That's no different than what you've done before. Okay, so whenever we talk about the angles, okay, you know from geometry that an angle is formed by two rays that have a common endpoint. They basically leave from the same point. We call it the vertex. Okay. Of those, the part that's new is that one ray is called the initial side, the other one is the terminal side. Okay. If you notice, whenever we draw, like how the angle, I'm going to say opens up, okay, like right here, see how it has the arrow going from one to the other? Wherever it starts is your initial side, wherever it ends is your terminal side. Okay. So your initial side of your angle is where your angle is like opening up from. So like if you think about the door, like if the door is closed, okay, the threshold would be like the initial side, and then as I open it up, the door becomes the terminal side. Does that make sense? Okay. So the initial side is like if you think about like a door opening, that's really what we're doing with any sort of angle. Okay, we're taking two parts, and then the hinge is really just that vertex. Okay, an angle in standard position. Okay, its vertex is the origin, and then initial side lies along the positive x-axis. Usually, is how we deal with it. Now, the next part talks about whenever we have positive and negative angles. Okay, so again, we always talk about or think about leaving it from like on a coordinate system, okay, or on that Cartesian plane where you have an x and a y axis. So we always start it at or on the x-axis. So it's kind of backwards as far as what you probably think, because if we move back in a counterclockwise motion, okay, we're going to open it up and make it positive. So as the initial side here and here, okay, in the blue, okay, as we open everything up, it's going to be a positive angle. Okay? Whereas if we open it down, okay, it's going to be negative. So it's kind of probably opposite of what you normally think, but if you think about everything that you already know about, like the points on your plane, is that up here in this top right, everything's positive. Okay, and as we go around, it's just going to work its way through. Now, I can open it all the way back up over here or kind of back in this direction, but again, it's all about how I move it. Okay? So if you think about things and, if I open an angle up 45 degrees in a positive direction, okay, so I open it up in a positive direction, I can do the same thing and I can get to the same spot and open it up in a negative direction and still get there. Okay? So we say that the angle lies in a quadrant of the terminal side. So wherever the angle ends, okay, that's what quadrant you're in. So again, this should be one that you should remember, that whenever we count, here's 1, here's 2, 3, and 4, as far as my quadrants are concerned. So depending on where it ends, okay, wherever that terminal side ends, that's what quadrant, okay, you are going to be in. Wherever it finishes, wherever your terminal side of your angle is, okay, you've got to make sure you go with that certain quadrant. And whenever we get to the trig stuff, we'll talk about like what angles are positive, whenever we talk about the trig ratios, whenever we talk about sine, cosine, tangent, so on and so forth. Okay. A couple other like housekeeping tips. If you notice here, you have different symbols. Okay. Those symbols are just Greek letters. I will tell you that theta, okay, the one down here in the bottom, this is the most common. That's probably what you saw a lot in geometry, okay, was theta. But whenever we talk about any sort of angle, it is going to be some sort of Greek letter, okay, and that's what's going to name the angle. So like if they say angle theta or alpha, okay, stuff like that. If you're not sure what it is, it's going to go through the Greek alphabet, but for the most part, theta is going to be the most common that you're going to see. Okay, it's one that you've already seen before, and then we just kind of go from there. Then, this is all stuff that you obviously should know. Measuring angles using degrees. Okay, if it's between 0 and 90, it's an acute angle. If it's between, or if it's straight 90, then it's a right angle. Obtuse is from 90 or above 90 and less than 180. And then if it's at 180, it's a straight angle. Okay. If you notice kind of with a right angle and a straight angle, you have a quarter rotation and you have a half rotation. Okay. What do you think a full rotation is going to be? If a half's 180, what's a full rotation? 360, right? It's a full circle. Okay. That's basically what we're getting to. Now, the nuts and the bolts of using angle measurements and using radians, or measuring angles using radians. Okay. A radian is the measure of a central angle of a circle that intercepts an arc length equal in length to the radius circle. Okay. Whenever we measure a radian, all we're going to do is we're going to measure the arc length around the circle, and then we're going to divide it by whatever the radius is. Okay? So for us to know what the radian measure is, okay, or of our circle, okay, or how we can measure that, is going to be whatever the arc length is. Okay? Because think about it this way, what's the circumference of a circle? No, that's the degree measurement. How do we find the circumference of a circle? Circumference is equal to times pi times r, okay? Or pi times the diameter, right? Okay. Basically what we're doing is we're taking a section out of that. Okay? We're going to take a section out. We're not looking for the whole thing, but we're going to take whatever that arc length is from one part of the circle to the other, okay, or one angle to the other. And then we're going to divide it by whatever the radius is. Well, what's going to happen there? It's going to divide by those pi's and the r's and everything else are going to cancel, okay, because we're going to have a certain length and kind of go from there. Okay, so your S is just whatever your side or your arc length is, and then you're just going to divide by whatever the radius is of your circle. Okay, it's all derived off of the circumference of your circle, is really what it is. But it'll be written, instead of it being written in terms of a degree measurement, okay, it's going to be written in probably a pi over something with a fraction, okay, or at least whenever we get down with the angles and stuff like that. So it says a central angle theta in a circle has a radius of 6 inches and an arc length of 15. So if I want to know what the radian measure of theta is, what's my S and what's my R? Which one's S? The 6 or the 15?
Your S?
My S. The 15. What's my radius? The 6, because it says the radius is 6. Right? So all I'm going to do is I'm going to take my formula here. So theta. Okay, all I do is just draw a circle. Okay, if you need to, I'm just going to draw like an oval, and then I usually do it like that. Okay, it doesn't have to be anything fancy. So then all I'm going to do is I'm going to take 15 and I'm going to divide it by 6, and I will reduce it. So I'm going to have 5 over 2. Okay, or you could say 2.5 radians. Either 5 over 2 radians or 2.5 radians. It's completely up to you. Okay, I really have no preference as far as if you want to write it as a decimal or if you want to write it as a decimal or as a fraction. Excuse me. So central angle, radius of 12, arc length of 42. What's the radian measurement? How am I going to set it up? What do I need to do first? What's on top? What's on bottom? 42 over 12. Okay. Again, you can, if you want, you can simplify this. You can divide both of these by 6 and have 7 over 2. Or you can just call it 3.5 radians. Now, kind of the last two things. One is the relationship between degrees and radians. So you're going to be given a degree and you're going to write this in terms of a radian. So if you go from degrees to radians, you're going to multiply whatever your degree measurement is by pi over 180. Okay? I'm going to give you a hint. Okay? Whenever you basically go over to, if you go 180 degrees, okay, a full circle, and we'll get into this whenever we go into the unit circle next week, a full circle is 2 pi. Okay? Pi is a half a circle. What degree measurement is a circle, a half circle, excuse me, semicircle? If a full circle is 360, what's a semicircle? 180. So realistically, what is pi over, or pi radians over 180? If a full circle is 2 pi in radians, and a full circle is 360 degrees, and a semicircle is pi radians, and a semicircle is 180, realistically, what are we doing? What is pi over 180? 1. right? Okay? They mean the same thing. Pi radians and 180 mean the exact same thing. It's just two different terms or two different measurements, basically, is what it is. All we're trying to do is go from one to the other. Same way when we go from radians to degrees, we're going to multiply by radians, which is just going to be 180 over pi. We're just going to flip the order. Because realistically, what are we trying to do? If we have 30 degrees, okay, or 30 over 1, and we're going to multiply this by pi over 180 degrees. What are we wanting to do? What are we wanting to get rid of? We're wanting to get rid of the degree measurement, right? So what's going to happen with the 30 degrees and the 180 degrees? They're going to cancel, right? Or they're going to simplify or reduce, whatever you want to call it. So the 30 is going to go away. What's the 180 going to turn into? A 6, right? So if I'm going 30 degrees and I'm going to write this in terms of radians, I'm going to have pi over 6. Okay. Do the same thing with 90. Okay, and I'm just going to multiply it by pi over 180. That's just 90 over 1. What's the 90's gone? What's the 180 going to turn into? 2, right? So I'm going to have pi over 2 radians. Same way if I go in the negative direction. That doesn't change anything. I'm still going to do everything the same way. I'm still leaving my angle from the x-axis, but instead of going up and to 135, I'm going to basically bend it down to 135 degrees. So nothing changes as far as how I simplify this or change the terms. I'm still going to go pi over 180. You've got to pay attention and make sure you keep that negative. So I need to reduce 135 over 180. So that one is probably a little bit more tricky. That's okay. It is going to be negative. 135 and the 180 reduced to 3 over 4. I would normally just put 3 pi on top. Okay, if you go 3/4 pi, I'm okay with that. But usually the pi is going to stay on the top side, and I'm going to have 3 pi over 4 radians. It's not going to change if I go from one to the other. Okay, if I go from radians to degrees, I'm going to do everything the same way, but instead of pi over 180, I'm going to go 180 over pi, because what do I want to reduce, or what do I want to cancel? I want the pi's to cancel. So if I have pi over 3 and I'm going to go 180 over pi, well, the pi's cancel. What's 180 divided by 3? 60 degrees, right? You're just manipulating. All you're doing is manipulating one to where you can get it to change to the terms that you want. Okay? There's no fancy tricks. There's no fancy formulas, nothing like that. All we're doing is just manipulating either where pi goes or where 180 goes. They mean the exact same thing. It's just a matter of, if you start in radians, you're going to have to convert it to degrees. If you start in degrees, you're going to have to convert it to radians. So for sure don't overcomplicate this. So if I have 5 pi over 3, it's going to be equal, or I'm going to multiply it, to 180 degrees over pi. Well, the pi's cancel. The 3 and the 180 is going to become a 60. Still need to multiply -5 and a positive 60. So I'm going to get a negative 300 degrees. Now, where C is a little bit different, where what don't you have? It says 1 radian. What have we had on A and what have we had on B? We've had a pi, right? So if I have 1 radian and I need to convert this into a degree, so I'm going to have 1 over 1 times 180 over pi. Now, the key here is make sure whenever you type this into your calculator, you leave pi as pi. Do not change it to 3.14. So again, do not change pi. No. No. No pi for you. Come back 1 year. No changing pi to 3.14. So all I'm going to do, so this one's just 1. So I'm going to take 180 and I'm going to divide it by pi. So I'm going to go to whatever calculating device that I have. Okay, I'm going to have to open mine. And all I'm going to do is first make sure all my stuff here is done. I'm just going to hit 180. Now, it tells me, depending on what you have, it's in radians right now. Okay, I want to make sure that I am in degrees. So, in doing that, I want to make sure that it's selected in degrees, because if not, it's going to give me kind of a messed up number. So I'm going to have 180 divided by pi, not 3.14. And then I'm going to get 57.295. I'm just going to round this to 57.3 degrees. Okay. Now, again, you've got to make sure that you're in the correct mode, so it needs to be in degree. If you're not sure if you have a graphing calculator, you want to go to mode and make. Okay. Good question, because that's what I was going to do next. So it's going to write it in terms of, so if I do everything the same way, okay, this one works out to where everything's okay, right? But whenever we get into, it's not really going to change a whole lot until we get into like the trig functions, okay? And we talk about like side lengths and stuff like that. That's when your mode that you're in, okay, is going to be affected. Okay? So it's going to be changed as far as like how it's going to be written, and you're going to start to see a pattern, hopefully, whenever we start to do like pi over 6 and what that means as far as, 30 degrees or whatever we're dealing with. Okay? Or what pi over 2 is with 90 degrees or 45 degrees and pi over 4. Okay? A lot of that will come whenever we get into the trig functions and stuff like that. Right now it's okay, but just know that for all intents and purposes, for now, you want to stay probably in degree measurement, okay, until we get told, or until you get told different. The last thing is really just talking about I just kind of cut you loose, because we'll talk about coterminal angles tomorrow, is that if you have any sort of, if you're going to draw an angle, okay, so if I'm going to draw an angle, we've already kind of talked about this before, that I have a circle, kind of here, okay, that right here is 0, right there is pi. Okay, and we'll get into the unit circle later. Okay, so as we go, if I'm going I'm going pi divided by 4. Okay, so if we think about it, where's up here? If this is pi and that's 0, what's the point up at the top? Pi over 2? Isn't it halfway? Does that make sense? We start at 0. If we open it all the way up, we're at pi. What did we do here? We went halfway, right? So then where is pi over 4 going to open up to? Kind of in between right here, right? Okay. Now, if we go, there's pi over 2, there's pi. What's down here? Nope, it's not negative. The only time it's negative is when we go this direction. It's always going to open up positive here. If we go negative, then we're going to go here. Okay, then we drop down and we kind of peel it back. Okay, so like 5 pi over 4. So if I go 5 pi over 4, where do I have to go? I have to go past 1, right? I have to go past 1 pi, and then somewhere maybe down here. That makes sense? Okay. I have to go, 5 over 4 is bigger than 1, right? Okay. So I have to open it up past 1 and then kind of taking the hands of the clock, okay, and going from there. Whereas if I'm going to go negative, so if I start here and I'm going to go negative, which way am I going to peel? Am I going to peel it this way or am I going to peel it down? Am I going positive or negative? This is positive, right? Oh, you can't see that. Sorry. That's positive, right? Okay, but what do I need to do? Peel it down. So do you agree that that's negative of a half? Yeah? So where's 3/4 going to be? Kind of back here. Okay? So there. So what do you notice about positive 5/4 and negative 3/4? Same spot. Okay? It's kind of like if you leave this room, it's not a circle, okay? But I can go out to the right, I can make 4 right turns, and I can end up back in this room, right? Dylan can go out the door, and he can make 4 left turns, and where's he going to end up? Same spot. Okay? Or he can end up taking 1 right turn and get to the corner where you can take 3 left turns and you can end up at the same corner. Does that make sense? Okay? So in some cases, now it's real simple if you think about it. What's 5 plus 3? 8. If pi's here, what's all the way back around? Well, 360, but what about in terms of pi? 2 pi. What's 8 over 4? 2. Okay? Since we're dealing with fourths, 3 plus 5 is 8. Okay? And it'll start to come as we start using this a little bit more. Okay? And kind of going from there. All right? It'll be a lot easier to kind of pick up as far as where it's going and what you're doing. Okay? The biggest thing is whenever you go positive, just understand that basically if my arm is here, I'm going to take it up to my head. Whereas if it's negative, okay, my elbow can't bend there, but you get the idea. Right? It's going to go down to my weight. Oh, that's disgusting.